You may have heard of a weak map, but what really are weak maps? To understand this better, we first have to look at regular maps. A map is a special type of object that also allows us to create entries, but the key can be of any data type, including objects. And in JavaScript, objects are handled by reference. So whenever we use an object as a key in a map, this key is essentially just a pointer to that object's location in memory. So using a map can be incredibly useful for adding some additional metadata to an object without directly modifying that object. For example, here we have a tokens map, a user object, and then we create a new entry with the user object as the key. This key now contains a pointer to that user object in memory, and then the value is a string with the session token. And this works perfectly. We can now retrieve this token by using the get method and passing that user object. But the issue here is with garbage collection. Now imagine that a user logs out. For this demo, we'll just set user to null. Now setting user to null removes that reference that user variable had to the user object in memory. However, the tokens map still holds a reference to this user object through its key. The issue is that a lot of JavaScript engines use a garbage collection technique that checks which objects are still referenceable from the global scope. In this case, the tokens map is still reachable from the global scope, and this in turn still references that user object. So this user object will not get garbage collected. But now we're kind of in this awkward position because we've lost that original reference to the user object. There is no way for us that we can still retrieve this entry from the map, but it is still taking up memory. So this is where a weak map comes in. Weak maps also allow us to use objects as the keys for their entries, but this time they hold a weak reference to that object. Weak references are ignored by the garbage collector when it tries to decide which objects are still reachable from the global scope. If an object is only referenced through a weak reference, it is eligible for garbage collection. Now when we nullify the user, we remove that strong reference that user variable had to the user object in memory. So now the only reference to this user object is through that weak reference from our weak map. This is now also eligible for garbage collection, and it will eventually be removed by the collector. And the nice thing is that whenever a keys object is removed, the entry in the weak map is automatically removed as well. But because of this behavior, we cannot iterate over or get the size of a weak map because the garbage collector can run at any moment, even during iteration. Entries might disappear at any time, which would make the iteration very unreliable. So using a weak map is perfect if you want to add some additional data to an object, and weak maps help to prevent memory leaks as they do not prevent objects from getting garbage collected.